Hey, what's up guys? This video is for section 7.7, which is geometric sequences as exponential functions. So you guys will see the relationship between a geometric sequence and an exponential function. In my previous video, we talked about how to graph exponential growth, exponential decay. So right now, we just need to learn what is a geometric sequence and how they relate, how they are similar to each other. So first, a geometric sequence. Let's go ahead and look at that. So the word sequence means when you guys have a list of numbers, and when you look at the numbers, there's a pattern happening. Now sometimes you can be adding to get the next number, sometimes you can be subtracting, but today we are going to look at multiplying. In order to be a geometric sequence, you have to be multiplying to get to the next number. So if you look at this sequence I have here on the screen, which is number 1, you have the numbers 1, 2, 4, 8, and it stops. So if you look at the pattern, well, you have to be multiplying by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8 in order to get the next number. So this is a geometric sequence. And I'm going to put here on the bottom that we are multiplying times 2 right there. Now, number 2 is a little bit hard, but you guys can also have fractions in geometric sequences. So you start with the 3, and then 9 over 4, and then 27 over 16. So you guys have to look at what are you multiplying to get to the next number. Now fractions, like I said, it's a little bit tricky. Most people, they actually shut down when they look at fractions, but simple guys. When you look at the fractions, make sure that every number is a fraction. So this 3, I'm going to make it a fraction, 3 over 1. When you guys have that fraction, well, you guys can look at what's happening to the top and what's happening to the bottom. So on the top, look at the numbers, 3, 9, 27. Now it's more clear to see that you're multiplying by 3 on the top. 3 times 3 is 9, 9 times 3 is 27. On the bottom, you're multiplying by 4. 1 times 4 is 4, 4 times 4 is 16. And notice we have dot, dot, dot. This means that it keeps going and going and going. So you guys can have more fractions, more fractions, more fractions, more fractions. But the number that you guys are multiplying, let me put that here. You are multiplying, so there's a times, 3 on the top and 4 on the bottom. So you are multiplying by a fraction, 3 over 4. So every time you guys do have that fraction, it's a lot easier to make every number a fraction and just check what's happening to the top numbers, what's happening to the bottom. Now that number that you are using to multiply to get the next number, it has a name. And the name is common ratio, and the variable is r. Common ratio. Common ratio is that number that you multiply to get to the next term. Terms are just the numbers you have in the list. So the first number is your first term, second number is your second term, third term, fourth term, and so on and so on and so on. So you guys have different terms. Now, if you guys cannot see what is the common ratio, well, we have a little formula we can use. This one here. A2, which is the second term, divided by A sub 1, which is the first term. So you guys can divide those two terms. Another way you guys can look at it is by making a fraction. And usually I make that fraction myself. When I look for the common ratio, I'm going to put R here. I'm going to use the same division, but I do second term over first term. That's what I do. But it's basically dividing the two terms. Second term divided by the first one. So A sub 2 divided by A sub 1. In arithmetic sequences, now this is going back in my class, we talked about arithmetic sequence first semester of the school year. So arithmetic sequence, just to review with you guys and so you guys can remember, we have a common difference. A common difference in arithmetic means you are adding to get to the next number, or maybe you're subtracting, but subtraction is really addition of a negative number, but you guys are, by definition, you guys are adding to get to the next term. So arithmetic sequences, to find the difference, common difference, you take the second term and subtract the first one. So second minus the first one. That's arithmetic. You have to add to get to the next one. But today, we are learning geometric, where you guys have to multiply, and it's called, the number you multiply is called the common ratio. But you also have to know the difference. I'm going to give you guys a couple of examples where you guys have to know if it's arithmetic or geometric, because you have to know the difference between the two. So let's look at those examples. So first, let's practice how to find the common ratio for these sequences. I have 3 sequences on the screen, and you guys notice that some of them, they do have positive negatives, and the third one has a negative, fractions in that third example right here. So let's try this one here, okay? So we have 2, 6, 18, and it keeps going and going and going and going and going. So you guys have dot, 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 dot. When a sequence keeps going like this, it has dot, dot, we say that's an infinite sequence. So it goes to infinity. It keeps going and going and going. But let's look at that number that you guys have to multiply. Sometimes it's this simple. You guys look at the numbers, 2, 6, 18. Well, you guys are multiplying by 3 on this one. So I'm just going to put here 2 times 3, that's 6. 6 times 3, that's 18. And to get the next one, you multiply by 3. So my common ratio is 3. Now, just in case you guys don't see it, if you don't know, oh, how do I get the common ratio? Well, you guys can divide. When you take the second term divided by the first one, the first one is the first number. So this is my first number here, a sub 1. And my second number is my second term, a sub 2. So if you actually do the division, a sub 2 divided by a sub 1, well, you guys would get 6 divided by 2, and you reduce. 6 divided by 2 is 3. So we get the same answer when you guys do the little division, or you guys just use number sense. You guys can do that. Now, sometimes you guys have negative numbers. So let's look at the sequence in the middle. Negative 40, negative 20, negative 10. Let me give you guys a tip. When you guys have all the signs equal, so negative, 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 they're all the same, or all the signs are positive, like this one here, positive number, positive number, positive number, and this one is negative number, negative number, negative number. The tip I'm giving you guys is the common ratio has to be positive, because in order to keep the same sign, you guys need to multiply by a positive number. Look at this one here. Over here, we have a negative fraction, and then a positive fraction, and then a negative fraction, and the next one will be positive. So there's a pattern. Negative, positive, negative, positive, negative, positive. So that means that your common ratio is going to be negative when the sign change, they interchange, a negative, positive, and so forth. So let's look at one in the middle here. So I know my common ratio has to be positive because they have the same sign. I really don't know why you have to multiply, let's say. So you do the little division. In order to find the common ratio, I'm going to take my second term divided by the first one. And second term is right here, second number. My first term is right here, the first number. So I'm going to set up my division. So I'm going to have negative 20 on the top divided by negative 40 on the bottom. Now you guys know that the zeros you can cancel in a fraction. A negative divided by a negative is going to be positive. So those two negatives turns positive. And you guys can reduce the fraction 2 over 4. And let me just highlight that for you guys here. 2 over 4, that is 1/2. And you guys are multiplying by a fraction. Your common ratio is 1/2. So we got this one. Now let's look at the fractions, okay? On the fractions, you guys notice that we have different signs, first of all. So when you guys have different signs, I already talked about the little tip I gave you guys. The common ratio has to be negative because we have a negative, a positive, negative, positive. If you multiply a negative times a negative, it's a positive times a negative, it's a negative times a negative is a positive. That's why the common ratio has to be negative. So let's set up this one here. So R equals, it has to be negative, first of all. So there's the negative. Here's the fraction line because I need to see what's happening to the top numbers and the bottom numbers. So let's see the top numbers. I have a 1 and a 1 here, and then a 1 and a 1 over here. Okay, so that means you are multiplying by 1. 1 times 1 is 1, 1 times 1 is 1. On the bottom, you guys have a 3 and a 6, and then from a 6 to a 12. Well, I need to multiply by 2. 3 times 2 is 6, 6 times 2 is 12. So my common ratio is going to have a 1 on the top and a 2 on the bottom. And it's negative because the signs are interchanging. So my common ratio is negative 1/2. Can you guys do the division, second term divided by the first one? Yes, you can. But remember that when you guys divide fractions, you will have to flip the fraction of the second one, and then you guys multiply. So I'm going to do that for you guys, but this is just another way. When you guys divide fractions, it's another way to find the common ratio. But I just show you guys how to do it without dividing the fractions. You look at the pattern on the top of the fraction. You could look at the pattern on the bottom. So let me show you guys how to divide fractions here. So you take the second term, so 1 over 6, divided by the first one, negative 1/3. Notice that we have a negative in the bottom and a positive on the top. So that's going to be a negative. And when you guys divide fractions, well, the bottom fraction, this one here, you guys have to take it to the top, and then you guys flip the fraction. Remember that when you divide fractions, you have to multiply by the reciprocal, which means you flip. Now you guys notice that little thing I did here? You flip the fraction, flip, and then you multiply to the top number. So let me just show you guys that here. R equals 1/6 times negative 3 over 1. You flip the fraction on the bottom. You don't change the sign, you keep the sign, but you flip the fraction. So this 2 simplifies, 1, and this is 2. So when you guys do that, well, my common ratio is negative 1 on the top and 2 on the bottom when you multiply the fractions. So we get the same thing, but I think that's a little bit more work when you guys try to divide the fractions. So this always works here. You look at the pattern on the top, you look at the pattern on the bottom. Make sure you guys check your signs. If the signs are different, then the common ratio has to be negative. If the signs are the same, then the common ratio has to be positive. So now let's go ahead and identify if a sequence is geometric or arithmetic. Just a review for you guys. Geometric is when you multiply to get to the next number, the next term, and arithmetic is when you are adding to get to the next term. So let's look at the first sequence here. We have a 4, a 20, 100. So common sense, number sense, or you guys can check if you're adding or multiplying by doing the little division or subtraction. But if you guys think about it, well, how do you get 4 to 20? One way is by multiplying by 5. 4 times 5 is 20. Now check again. You guys need to check if you multiply by 5 again, do you get the next number? So I'm just going to check here. 4 times 5 is 20, and 20 times 5 is 100. Oh, that works. So since we are multiplying, this sequence is geometric. And let me write down the common ratio. My common ratio is 5 because that's the number we are multiplying. If you take the second term, 20 divided by the first one, 20 divided by 4 is 5. So I'm going to put yes, this is geometric. Geometric. And you have a sequence. So you check. If the first time you check it doesn't work, then you try to check for a different number. So for example, if you think it's geometric, check if you multiply by 5, and if it doesn't work, well, check a different number, or you can also check if you're adding to see if it's arithmetic. So look at the second sequence. Negative 10, negative 8, negative 6, negative 4. So the numbers, you guys see that they have the same number. Maybe you are multiplying, maybe you are adding. So if you look at the negative 10, well, what do you need to, if you think it's geometric, let's say right now, I think it's geometric, what do I need to multiply this to get negative 8? So it's kind of hard to know. One thing you can do, if I think it's geometric, I can take the second term, so this is my second term, negative 8, and divide by the first one, negative 10. So this is my first term. And when I simplify the fraction, well, it's going to become positive, and you guys have 4 on the top, you divide by 2, and 5 on the bottom. So if this is my common ratio, if I need to multiply by 4 over 5 every time, well, let's check. If I multiply this number, negative 8 times 4 over 5, am I going to get negative 6? And I'm going to show you guys the work here. Negative 8 times 4 over 5. So you guys convert the 8 into a fraction. You multiply the top. That'll be negative 32. And the bottom is 5. And this here does not simplify to negative 6. So guess what? We are not multiplying to get to the next number. So that means that we have to add. So the question is, what do I have to add? Now let me erase all this here so we can check arithmetic sequence. And for arithmetic, we do have a common difference. So I'm going to put a D right here. And common difference, you take the second term and subtract the first term. So this is my second term, this is my first term. So I'm going to get -8 minus, and I do have a negative number for my first term, so I'm going to put parentheses, -10. We do have double negatives, so I'm going to do plus plus here. So my common difference will be -8 plus 10, 2. So you guys check. Are you adding, let me put a D here, are you adding 2 to get to the next term? Well, -10 plus 2, -8. -8 plus 2, -6. -6 plus 2, -4. It works. So this one is arithmetic. And because we found out we are adding 2 to get to the next term. So one is geometric when you multiply. The second sequence is arithmetic because you're adding. Let's look at the third one. The third one, you guys have 5, and we have a -10, 20, 40. Oh, wait a minute. I think I'm multiplying. 5 times 2 is 10, but I need a negative, so that means I have to multiply by -2. So let's check. 5 times -2. Yep, that's -10. -10 times -2. Yeah, that's +20. Let's try this one. +20 times -2. No. +20 times -2. That's actually -40. So we don't get 40. So it seems like you are multiplying by -2, but the last number doesn't work. So that means it's not geometric. So let's erase this work and try if it is arithmetic. So we have to check if you're adding. So let's see here. So if you are adding, well, if you take the second term, so let's say we are adding the second term minus the first one, and the first one is 5, so I'm just going to put a 5 right there. Well, if you are adding, the common difference should be -15. So if you take 5 plus -15, well, that's going to be -10. But you guys need to check the next one. If you take -10 plus -15, and let me just show you guys down here, -10 plus a -15, that's going to equal -25. Nope, we don't get -25, we have a 20. So we are not adding either. So that means we are not multiplying or adding. So this is neither. You guys don't have a geometric sequence or arithmetic sequence. So it says here to determine if it's geometric, arithmetic, or neither. So this one is neither. And that's how you do, guys. There's no really trick to just know what it is. You have to check. You have to use common sense, number sense, and you guys just try. If you multiply, do you get the next number? Or are you adding to get to the next number? Or neither works. So you guys don't have a geometric or an arithmetic sequence. All right, so now let's just use that concept of geometric sequences. We have to multiply to get to the next one. So here, I'm just asking you guys, what is the next 3 terms in the geometric sequence? So when you look at the sequences, first of all, we know it's geometric, so we need to find the common ratio, and then you just keep multiplying to get to the next one. Now we are looking for the next 3 terms. So here, the first sequence, we have a 2, a -10, and then we have a 50, sorry. So it is geometric. We know you have to multiply. But now we need to know what number you are multiplying. So I'm going to take the second term divided by the first one. And you guys probably already know what is the number you're multiplying. But if you take the second term, which is -10, so this is my second term, and this is my first one, and divided by the first one, well, I am multiplying by a -5. So R equals -5. You multiply by a -5. So now you guys multiply that to get the next term. So I'm going to show you guys a little notation that you guys know, I need to know. So we know the first term, second term, my third term is a sub 3. So the next one should be my fourth term. So I'm going to put a sub 4. So I'm going to take 50, which is the previous one, the third term, and I multiply by -5. and that's going to be negative 250. Now I need to multiply again. So my next term, a sub 5, which is the fifth term, I'm going to take negative 250 and I'm going to multiply by the common ratio. Common ratio is negative 5. So I multiply by negative 5, and that's going to equal positive 1,250. So we got two terms. We got the fourth term and we have the fifth term. But now we're looking for the next one because it's asking for 3 terms up here. So the next one you just multiply, and that's going to be your sixth term. So my sixth term is 1,250 times the common ratio, negative 5, and that's going to equal negative, and we have 6,250. Now you guys use a calculator. That's fine, guys. Use the scientific calculator. You multiply by negative 5, multiply by negative 5 to get to the next term. So that's the first example. Now let's look at the next sequence. The next sequence, you guys have a 36, a 12, and a 4. Well, the numbers are decreasing, okay? Since the numbers are decreasing, you guys need to be multiplying by a fraction. Now, how do you find that fraction? Or you might say you are dividing. If you look at the numbers really, really close, well, you guys are dividing by 3. 36 divided by 3 is 12. 12 divided by 3 is 4. When we say division, divide by 3, that's actually saying multiply by 1/3. But let me show you guys the actual formula for the common ratio. So the common ratio is second term divided by the first one. So I have second term, first term. And when you guys reduce 12 over 36, yeah, you divide by 12. So that'll be 1 on the top and 3 on the bottom. So my common ratio is 1/3. So you are multiplying by 1/3. So let's see here. I have 3 terms. So this is my third term here. So my next one is my fourth term. So I'm going to take 4 and I'm going to multiply by the common ratio, 1/3. So that's going to be 4 over 3. And then I find my next one, my fifth term. I take 4 over 3 and multiply by the common ratio, 1/3. So that's going to be 4 over 9. And my next term, you take 4 over 9 and you multiply by the common ratio, 1/3. And that's going to be 4 over 27. Now you always want to check if you guys can reduce the fractions, but these ones here cannot reduce, all of these here. So my 3 terms that I'm looking for are these 3 right there. Those are my next 3 terms, and you guys can keep going. You can multiply by 1/3 every time to get the next one and the next one and the next one. So sometimes you might have a negative ratio, common ratio. Sometimes you might have a fraction. You just have to make sure that you get the next term every time you guys multiply. All right, now let's go ahead and connect the two concepts of exponential behavior or exponential functions and geometric sequences. If you guys look at this formula, I'm giving you guys the nth term of a geometric sequence. Why nth term? Let me just underline what I'm talking about. Nth term means that you guys are going to find many terms in a sequence. So when you start counting, fourth term, fifth term, sixth term, seventh, eighth, ninth, 10th, 11th, 12th, all of those end with a th. I know second term, third term don't have a th, but that's what we use. We use nth, the nth term, when you guys have a sequence. So when I ask you guys, what is the 11th term in the sequence, you guys can use the formula. Now, what is the formula composed of? Well, first we have a sub n, so a to the n, a sub n, equals a sub 1 times the common ratio, and the exponent is n minus 1. Notice that I'm using a parenthesis here because I want you guys to differentiate between the first term and the common ratio. So you guys are going to multiply those two. When you put the numbers together, some students, if they don't use parentheses, some students think that it's a one number, but it's actually 2 numbers. One is the first term and the other one is the common ratio. What do we need? We need to substitute the first term, so a sub 1, the little one tells you the term that you need. So we need the first number in the sequence, first term. We need the common ratio. You're going to substitute the common ratio in the parentheses, the first term. And we have the exponent of n minus 1 here. N is going to be the term that you're looking for, and this n is the same one as over here. So n is the term, for example, if you're looking for the 11th term, well, n is going to be 11. So you guys will put 11 here. Once you guys do that, you simplify using a calculator, and you guys can find a specific term using the formula. So first, you need to know how to come up with the formula, because usually a sequence, they don't give you guys the formula, the nth term. That's what we need. We need the nth term, the formula, which is all this here, in order to find the specific term. So let's try an example here. So we do have, we want to write the nth term for the sequence and find the sixth term of this sequence. So first, let's go ahead and find the nth term. So I'm just going to highlight here so you know what we are looking for. So the nth term, we need the first term of the sequence and the common ratio of the sequence. So let's look at the sequence here. I have a 4, a 20, 100, and 500. Sometimes it's really simple to look at the numbers. Common sense, you can find the number that you are multiplying to get the next one. So I noticed that 4 times 5 is 20, and if I multiply again, 20 times 5 is 100, and 100 times 5 is 500. So I know my common ratio is 5, and my first term is actually the first number. So a sub 1 here, a sub 1, my first term is 4. And I'm going to put the common ratio is 5. That is the one we are multiplying to get the next term. So all we need is the formula, a sub n equals a sub 1 times the common ratio, and we have the exponent of n minus 1. You are going to substitute the first term in the common ratio, and you don't worry about the n. Every time you guys look for the nth term, you're not going to substitute a number into the n. So we have a sub n equals 4, that's my first term. Common ratio is 5, so I substitute a 5, and the exponent is n minus 1. So this formula here helps us find any term in that sequence. And I mean the first term, second term, third, fourth, fifth, the 27th term, whatever number you need to find, we can use the formula, and that's going to give us the value. Now, the question here says, what is the sixth term? So now I'm looking for the sixth one. And you guys, obviously, you probably already figured this out, but you guys can multiply by 5 every time until you get to the sixth number. So this is the first term, second term, third, fourth. So to find the next one, the fifth one, you multiply by 5, and to find the sixth one, you multiply by 5 again. You can do that, but you need to know how to use the formula, because this number here, in different textbooks, they might ask you guys for the 37th term or the 97th term. So that's going to be a lot of work if you multiply by 5 times 5 times 5 times 5 times 5 multiple times. So to find the sixth term, we are going to have n equals 6, because that's the term that we're looking for, the sixth term. So in this formula, I'm going to substitute 6 into the n, and I'm going to substitute, after I substitute, I'm going to simplify the equation. So I have a sub 6, so there's the 6, 4 times 5, that's your common ratio, and we have n 6 minus 1. So we have 4 times 5 to the 5th power. Now using a calculator, you guys can find out what that is. And the number a sub 6, which is the sixth term, is 12,500. So that is the sixth term. Now what does it mean? This is what it means, guys. When you multiply, let's say that you guys start with from the beginning of the sequence. 4 times 5 is 20. 20 times 5 is 100. 100 times 5 is 500. And if you multiply 500 times 5, that's going to be 2,500. So the next one, 2,500 times 5, is this number here, 12,500. So the formula helps us find the specific number that we're looking for, instead of multiplying and multiplying and multiplying and multiplying in the sequence. So let's try another example. So this one, we want to write the nth term, same thing, of the geometric sequence, and we want to find the 8th term. So notice, first we have a number, negative, an integer, -8. Then we have a +2, and then we have a negative fraction, 1/2, and it keeps going and going and going and going. So this sequence, you guys can find more numbers but we want the nth, the actual formula, and the 8th term. So first, let's look for the nth term. So the nth term is going to be, I need two things. Number one, I need my first term. So my first term is right here. That's a sub 1. That's your first term, so that's -8. And my common ratio, well, looking at the numbers, you might say, well, it's kind of hard to know what you need to multiply -8 times something that gives you 2. So you guys can do the little fraction I showed you guys to find the common ratio. And to find the common ratio, you take the second term divided by the first one. So we need the second term. Second term is right here, 2. So when you guys substitute, my common ratio is going to be 2 over -8. That's the first term. Reduce the fraction. So my ratio will be -1 over 4. 2 over 8 reduces to 1 over 4. And since we have one negative, notice, remember here on the bottom we have a negative. The top is positive. So we keep the negative. A positive divided by negative is negative. So that is my common ratio. So my common ratio is 1/4. So now you guys are ready to find the formula. Now you guys need to know what the formula looks like. So make sure you guys memorize it. We have a sub n equals a sub 1 times the common ratio with the exponent of n minus 1. We don't worry about the n for the nth term. We're just going to substitute the first term. So a sub n equals -8. And we multiply by the common ratio, -1/4, and the exponent is n minus 1. When you guys use calculators, make sure you use parentheses every time you guys have a fraction for the common ratio, or if the common ratio is negative, also make sure you guys use parentheses because that makes a big difference for your answer. So this one here, we got the formula, the nth term. So this formula is going to help us find any term in that sequence. Now this sequence only gave us three numbers, but we want to find the 8th one. So you guys go 1, 2, 3, 4, 5, 6, 7, the 8th one. What is the number on the 8th term? So for my 8th term, that's what we want, 8th term, I need to use the formula. So let me just put here 8th term. N is going to equal 8. That's the term that I'm looking for. I'm going to substitute 8 into the formula. So a sub 8 equals -8. You guys take the ratio, common ratio, -1/4. And we have 8 minus 1. N minus 1 is your exponent. So we have a sub 8 equals -8 times -1/4. And we have the exponent of 7. So now using the calculator, you guys can find the value. And the 8th term is... Now this is as a fraction, my answer, but the 8th term is 1 over 2048. So we do have a small, very small fraction, and that's my 8th term. Now keep in mind guys, remember that I told you a little tip, when the signs interchange, when they change from negative, positive, negative, the next one will be positive, negative, positive, negative, positive. Your common ratio has to be negative. And it makes sense that this is positive because it changes. So common sense, the 8th term is positive. So the next term, the 9th one, let me just say this is the 9th one right here, is going to be negative because you guys interchange the signs. So let's try another example. And for this example, it's a little bit easier because we do want to find the nth term. We want to find the 5th term, but they give us the first term and the common ratio already. So all we have to do is use that common ratio, you substitute, and then you guys can simplify to find the answer. So first, let's go ahead and find the nth term. So for my nth term, I'm just going to rewrite what we need, but we already have it. I need my first term, which equals 32, and I need my common ratio, which equals 3 over 2. So all you do now, guys, you are going to substitute into the formula, a sub n equals a sub 1 times the common ratio with the exponent of n minus 1. So we have a sub n equals the first term, 32, times 3/2, and we have exponent of n minus 1. So that's my nth term. Notice my fraction is, my common ratio is a fraction, and 3 over 2. And you guys have n minus 1 as an exponent. The next one we want is the 5th term. So now you guys are going to substitute So here's my fifth term. I'm going to substitute 5 into n. So n equals 5 because that's the term that I'm looking for. So using the formula, I have a sub 5 equals 32 times 3 over 2, which is the common ratio, and my exponent is 5 minus 1. So my fifth term equals 32 times the common ratio, and we have an exponent of 4. So using a calculator one more time, the fifth term equals 162. So that is my answer for my fifth term. Notice that it is a whole number. That can happen when you multiply by fractions. Maybe you also get a fraction, but it just depends how the problem works. Just make sure that you guys substitute the right numbers in the right place. So once again, this is the term, the formula that gives us any number in that sequence. And then you guys found the fifth term. Now, how can you actually do this by hand? Well, if you take 32 and you actually multiply by 3/2, that's going to give you guys the second term. And then you can take the second term and multiply by 3/2, that's going to give you the third term. And then you take the third term and multiply by 3/2, and you get the fourth one, and keep doing that, keep doing that, keep doing that, and keep doing that, and you guys can find the fifth term. By using the formula, like I said, guys, it's a little bit faster, and you guys need to know the concept of the formula. So just a quick review for you guys with the formula. We need the first term, which is in front of the common ratio, and we have an exponent of n minus 1. So this is the formula. When you find the nth term, you don't need to worry about the n. That's going to be your variable, but you need to substitute the first term and your common ratio, and that's it. So make sure you guys do your homework. Make sure you guys practice. This is the end of my video, and I'll see you guys later.